consider this problem. The time of swing, that is represented here as t, of a pendulum. So a pendulum is suspended on a fixed wall and it will be moving like this. This is the bob of the pendulum. Swing t, that is time of swing, is represented as t of a pendulum is given by t is equal to k into square root of L, where k is a constant. Determine the percentage error in the time, of swing if the length of the pendulum L changes from 32.1 centimeter to 32.0 centimeter. So this is the small difference in the length, and this is the determine the percentage error in the time. So it means this is nothing but dt by t into 100%. So we need to calculate the percentage error in the time. So the change of time is dt, t is the original time, and percentage error with respect to dl means, so we can take the original equation t is equal to k into square root of L. Is equal to k into, we can write L power 1 by 2. So let us differentiate this with respect to L. So dl, dt by dl, because that change is going to happen with respect to L. So dt by dl. Of course, this is constant, and this is 1 by 2 into L half minus 1. So that is equal to k by 2 into L power minus half. So dt is equal to, you can bring this dl here. Therefore, dt is equal to k divided by 2 into root L. We can bring this L power minus 2 minus 1 by 2 to the denominator, so it becomes plus. So L power minus 1 by 2 is nothing but root L. So root L into dl. Now the original timing is there. We want to find out this error. So dt by t into 100 is equal to, what is dt? The dt is k into 2 into root L into dl divided by t. So the original t is k into, this is the t, k into root L, now into 100. So therefore the percentage error in the t is equal to, so k divided by 2 root L and keep divided by 1, so that it will become 1 by k root L into dl into 100. Now let us substitute k, you can maintain as such. So the k can be cancelled and root L becomes L. Therefore 1 divided by 2 into L into dl into 100. The change in length is, that is DL, 32.1 minus 32 means 0.1. So this is the DL. We can replace this, and L is the original length, 32.1. Therefore 1, let me write on the other side. So 30% error in T is equal to 1 by 2L, 1 divided by this 2 into 32.1 into, and of course we have to change it from 32 to 32 minus 1. Okay, so let me write here, DL is equal to the final length 32, initial length 32.1, so there is a decrease, so 0.1 minus 0.1, so you have to put here minus 0.1 divided by, of course, 1 into 100, right? So that gives you minus 0.1 into 100, 64.2, that is 0.156%. This is the answer. You can mention this as the decrease in the swing rate. So the percentage error in the time of swing is a decrease, minus represents decrease of 0.156%. This is the answer.